Young friends, welcome to the course Manufacturing Processes 2. Our module ongoing is Jigs and Fixtures for machine shops, and the lecture today, this is the last lecture under this module Jigs and Fixtures, and today's topic is design and application of some jigs and fixtures for some specific jobs. Now, what are the specific instructional objectives today? Analyze economic viability and judge necessity of jig and fixture for a specific job. Now, whenever we get a task, we should decide, should we go for jig and fixture? That is to be decided with analysis. Then, if decided that jig fixture should be used, then we have to make a plan for designing a jig or fixture. Now, next is design fixture or jig configuration and working principle for some specific machining work. Some examples will be given for some typical jobs. Now, first, analysis of economic viability and judging necessity of jig fixture, whether jig fixture be used or should not be used. Before that, let us recall the machining work for a lot production, starting from few pieces to a large lot. There are three basic modes of lot production by machining. What are those? Using ordinary machine tool like lathe, milling machine, broaching machine, and similar machine tool, boring machine, without using jig or fixture. That is, total work will be completely manual, even marking and locating, clamping, everything will be manual. Using ordinary machine but with jig or fixture. You remember, according to definition, jigs and fixtures are the devices which enable easy, quick and accurate locating, supporting and clamping, but this will be done manually with the help of a human being, but will be done very easily, quickly and accurately. So, this will save time. Using automatic single purpose machine. Now, beyond these three modes, there are two modes also. One possible is transfer machine. Now, transfer machine is not a standalone machine tool, it is a group of machine tool arranged in a row comprising say 50 to 100 machine tools. So, this is highly automatic, we are not considering this thing at this moment. Work can be done also in CNC machines or even machining center. Yes, these machining centers, CNC machines are applicable for job order production or batch production, but these are very expensive, sophisticated machine. They should be used for complex jobs which are difficult to be done by other machines, conventional machines, and the value of the product is very high, so that the total revenue will compensate the cost of the machine. So, our discussion will be confined to the first three: using ordinary machine tool without fixture, using ordinary machine without or with fixture, using automatic single purpose machine. Now, it is obvious that ordinary machine, if we work by human, the cost of the machine is less, but the time will be large, the production rate will be slow. So, the machining cost per piece will be large. If we use jigs and fixtures, the cost of the machine remains same, but the additional cost of the jig and fixture have to be added. Now, if we do it automatic single purpose machine, work will be done very quickly, accurately, no doubt, and but the machine is very expensive. It has to be available and procured. Now, out of these three, we have to select one. Selection of manufacturing mode is governed by what are the factors by which based on which we shall select the mode for a particular production task. Technological feasibility of the modes. Okay, there is a task, machining task, and there are three modes possible. We have to check whether these three modes are feasible, technologically feasible for the task or not. For example, if the job is very simple and few, then it can be done in ordinary machine by the manual mode. But if the workpiece is a very complex, then it may not be possible to do it in automatic machine. If we try to do so, the cost of the machine will be tremendous. So, these are few technical feasibilities. Okay. Human being can take care of by virtue of his skill, understanding and intelligence, lot of complexity and all these requirements. Automatic machines are not of that type. technical feasibility. This really means we may select technologically, from technological point of view, a particular mode for a particular task, but it may not be technical feasible because the machine has to be available, jig fixture has to be available. If not, there should be some experts who can design and construct jigs and fixtures required for the purpose. If it is to be done in automatic machine, single purpose, then this machine has to be available. If not, at least has to be procured, that amount of money has to be available, and all this. These are called technical feasibility. Now, economical viability, that is the most important. This has to be based on considering cost of manufacturing. We are concerned with machining at this moment, not casting, forging, only semi-finishing and finishing by machining, based on the cost components, cost of the basic machine, because this machine will be used for a good amount of time. So, the cost of the machine has to be taken into account, which will remain engaged. Cost of design and construction of jig fixture, if this is to be used, because jig fixture has to be designed, these are not available in the market as such, they are tailor made, they have to be designed and constructed separately according to the job. So, additional cost will be involved. Volume of production, number of pieces, yes, it may be say piece production, 1 or 2 pieces, very few, up to 5. It can be job order production, say up to 5, 10, 20. It can be a batch production, it can be a lot production. Now, even if it is lot, it can be small lot, medium lot and large lot production. At the top of that, it can be mass production. So, the number of pieces has also to be taken into account. Material and labor cost, this has also to be taken into account. If time taken is too much, then labor cost will increase. If we can get the work done quickly with the help of say jigs and fixtures or with the help of automatic machine, then the labor cost will come down drastically. Beside this manufacturing cost, few more points are also to be considered. Expected product quality and revenue, yes. Now, can this mode provide the desired quality that is required, and what will be the revenue, because revenue minus manufacturing cost is the profit, that is the more important objective. Sometimes automation can provide quality consistently, and as a result revenue increases, but for complex jobs or if the number of pieces are very few, then the human being can do better, say manual production in case of piece production. So, they can also produce the desired quality and get the revenue. So, this factor has to be taken into account. Total time to complete production or deliver the products. Now, if you take a task, you can complete it in 1 month if you do manually without using jig fixture automation. If you use jig fixture, maybe within 15 days. If you do it automatic machine, maybe within 7 days. Now, if you can complete the work within 7 days and deliver, you will get lot of benefits. The customers will be very happy, they will pay more money for that, and you can utilize the time that is saved for other work. So, it has great impact on the socio economy if you can deliver the goods in time and in a short time. Now, after that, method of selecting manufacturing mode based on total production cost. Now, we have seen in the previous frame that there are so many factors. Now, out of which most important is the manufacturing cost. We shall give an example, it is discussed as an example of selection based manufacturing mode based on total production cost, that is cost of manufacturing by machining. Consider a case as an example. What is the case? Machining task. Now, suppose you have to produce 120 pieces of an object. Task is the estimated cost components for machining a product are as follows. There are 3 modes possible. Say mode number 1, W. W stands for ordinary machine without using jig fixture. Fixed cost, the machine cost will be 2 lakhs of rupees, and variable cost, that the cost per piece, that is the labor cost, material cost, will be 5,000 rupees per piece. If we use jig fixture along with the ordinary machine, then the cost will be high. Then we say 1 lakh extra for the jig fixture, 3 lakhs initial fixed cost, and the variable cost will come down to 2,500 from 5,000 because of saving time and reducing rejection, that will help reducing the cost per piece. Now, finally, if we go by mode A in automatic single purpose machine, the cost will definitely increase, initial cost, because the machine will be expensive, say 6 lakhs, and the running cost or the variable cost will be 1000 rupees per piece for the material and labor cost. Now, the question is, select the most appropriate mode out of these 3 given and decide whether jig or fixture will be necessary or viable if the number of pieces to be produced is 120. Now, this is very important. The decision will be, the selection will be finally governed by these components of the cost as well as the number of pieces or the volume of production. You can see later on. Next. Now, in this graph you can see that the first one, now this is a graph showing total machining cost, quantity of production. Now, what is the total cost? Total cost is CT is equal to CI, initial cost, plus Q, quantity of production, multiplied by M, marginal cost. That is Y is equal to Mx plus C. It is a straight line. Suppose we assume that these are going on as a straight line. Now, in the case of W, say this main production without jig fixture in ordinary machine, the initial cost is 2 lakhs. You can see in the previous one it was 2 lakhs, and the running cost or the varying cost is this much. Slope is stiff, that is M is large here because it goes slowly and the cost, labor cost increases, so it rises sharply. Next, if we use jigs and fixtures, say JF, ordinary machine with fixture, say JF, then the initial cost will be 3 lakhs, but the cost per piece will come down, the slope will come down because it is only 2500 rupees per piece. So, it will go like this. And if we use automatic machine, initial cost will be 6 lakhs, but the slope will be even slower, that is 1000 rupees per piece. Now, what do we understand from this? These 3 points of intersection are called break-even points. Now, here we can see this is the number of pieces to be produced. If the number of pieces to be produced is less than 40, suppose less than 40, then which one will be most appropriate so far as production cost is concerned? The bottommost line, here the bottommost line gives the minimum cost. What is that? That is machining in ordinary machine without jigs and fixtures. That is, if the number of pieces is very small, then maybe the machining in ordinary machine without jig fixture will be more economic than even jig fixture use or automation. On the other hand, here we can see that if the number of pieces is more than 200, then which one is most economic? Then the automation system is most economic because that is the bottommost line. So, for large lot production or huge production, mass production, automatic system is most economic. But friend, what about the region here, this region between 40 to 200 or say 41 to 199? We find that this line is the bottommost line. That means, if we use the machine and jig fixture, then this will be most economic if the number of pieces or the volume of production remains within this region 40 to 200. What is our problem? Our problem says whether should we use jig fixture or not if the number of pieces is 120. Now, if we draw a line, we find that this meets this bottommost line, which suggests that using ordinary machine and jig fixture will be most economic, in the sense manufacturing cost will be minimum. This is the how the mode is selected based on economic viability, and here we can find that this situation suggests that use jig fixture properly. Now, planning prior to design and construction of any fixture or jig. Now, suppose we decide that yes, for a particular task we shall use a jig and jig or fixture. Now, before we go into jig fixture, we have decided yes, we shall go for jig or fixture, but before that, before going into the real design and construction fabrication, we have to make a thorough plan and sequential steps. Now, for convenience of understanding, let a typical machining task be taken up as follows. What is the task? Task is this one. We take a rod. This is a rod okay, straight cylindrical rod of circular section of length L plus minus delta. That means length may slightly vary because of the tolerance, and a hole, this is the real task. A diametral through hole has to be made into this rod at a given distance. This distance is very important, this distance x plus minus delta. That means the distance should be precisely maintained within a small tolerance. Diameter of the blank may also vary because this rod, the blank is pre-machined by turning somehow. So, this will also may have some variation in the diameter, say delta d, small variation. So, locating, supporting and other things for the design steps should consider this aspect, the precise precision of the distance with the tolerance and variation, possibility of variation in the diameter of the rod because of this, and length can also slightly vary because of machining tolerance. So, briefly what is the task? A fixture or jig has to be designed and built for drilling a through hole, there is no blind hole, through hole in a pre-machined mild steel rod. So, it is a strong material at a given distance x plus delta x in a pre-machined mild steel rod at a given distance from one end face as shown below, this one. Okay. So, this is the task. Now, let us see planning for design. Now, we shall really show the schematic layout. We shall not go into the design for strength, rigidity, wear resistance, that we are not going to do, that is a separate issue. We shall design the for the configuration and major principle of working, like locating, supporting, clamping. Steps. First of all, we have seen the task. So, this is the rod job where a through hole has to be drilled in a transverse plane, whether jig or fixture. Now, should we use a jig or fixture? Now, this task says we have to make a through hole by drilling, okay, drill phi d. So, there is no tolerance, so no accuracy is required. So, drilling is best suited, most economic, and so a jig has to be used because the drill will need some tool guidance. As soon as you need a tool guidance and provide it, it becomes a jig. Positioning and orientation of the blank. How will you place the blank? Shall you place the blank horizontally, vertically, or in an inclined fashion? How? Now, here we can see a hole has to be made perpendicular to the axis. Now, this hole has to be made by a drill. Now, drill in a drilling machine is always in a vertical position. So, the drill axis is in vertical position and the hole has to be made perpendicular to the axis of the rod. So, rod has to be placed horizontally. So, drilling can be done vertically by the drill. So, this is the configuration. This will be the configuration. Rod will be kept horizontally like this. Locating the blank in the jig. Now, this location is very important, which was discussed in the previous class, previous lecture. Now, since it is a cylindrical rod of suitable, say, reasonable length and diameter, all right. So, this is pre-machined. So, considering these aspects, locating by V block is most appropriate. So, this will be supported by, located by V block. So, this is the V block, okay, on which this will be located. If the diameter varies, now drilling has to be done axially. If the diameter slightly varies, this will not make any problem because the axis will remain same. Now, there is another part using V block, and we should use a pin because this location is very important, isn't it? So, this has to be placed in a proper position along this line. This is also to maintain on one side locating by V block and locating this face, so that the drill axis is known. So, this distance will be maintained, and this is done by a pin, locating pin. Now, this pin should be locating pin adjustable because there is a tolerance desired. Now, after drilling, if there be any error in the distance of the location, then by moving this screw, operating this screw or rotating, this can be adjusted again and again as and when required. Beside that, in the next opportunity, if another job comes where the length of the job is slightly bigger or smaller, by adjusting the pin, the same fixture can be used. Next is supporting the blank against forces. What are the forces? Clamping force, cutting force, etc. will come onto the workpiece. So, this blank has to be supported on rigid bodies. Now, it is already decided that the job will be located on V block, all right, V block. So, this V block is strong and rigid. So, same V block will be used for supporting also. So, this will give the strong support to the blank. But since it is a long rod, it has got sufficient length. So, this V block should have some recess here. So, contact will be over this length and there is relief, so that the contact here and contact here are assured, and this will give more stable support. This is an important aspect. Now, come to clamping, planning steps going on. Now, clamping, this need to be easy, quick, strong, rigid and stable. So, these few points have to be kept in mind. Now, keeping those things in mind, this has been proposed. Now, remember friends that for making this thing understandable to you, I have given only one example, but remember there can be several options. Some of them may be as good or even better than what has been proposed by the teacher. So, this is one example, keeping in view that it should be easy, quick, strong, rigid, stable, as well as this will not hamper the loading and unloading of the blank before and after machining from the jig or fixture. Now, this is the rod, okay. This is the rod kept supported located on the V block, okay. Now, the clamping has to be passing through this point. So, this will give stable support. Now, here this clamping has been done by a quick clamping method, cam clamping. This has been magnified here. You can see here, this is the workpiece and this is clamped by a strap, and the strap will exert a force on this pin, and this will be exerted by rotating this lever of the cam clockwise in this direction, and then this will rise in this direction, this will exert force on the pin. So, the pin will not rotate, and this force will come onto the pin where a rocker, a pivoted arm is given, where the force will be exerted equally from these two sides, and there will be no rubbing or sliding area, only there will be point contact, and these two contacts plus these two contacts at the supports will give very stable clamping, and this cam, eccentric cam, will give a self locking. So, during machining this will remain in position. Now, on this view, this is other view, this is cross sectional view and this is other view, this can be shown here. This is a pivoted block. Now, here you can see the spring. What is the function of the spring? When this cam will be withdrawn, the spring will push the pin up, there will be gap between the pivoted arm and the job, and job can be easily released or removed. So, this has to be kept in mind. Now, step is continuation planning steps, tool guidance. In the previous one, you can see we have done locating, supporting, clamping. Now, here you can see through this clamping plate, okay, rigid plate, there is a hole, large hole through which the drill can pass. Now, we have to see that the drill has to start on a cylindrical surface. Drill as such is a slender tool which rotates. While rotating, it rotates in with a run out. That means because of run out, the diameter of the hole becomes oversized. Beside that, it has to start on a cylindrical surface, isn't it? The cylindrical surface drilling has to be done. So, drill has to be guided properly. It should not be allowed to move apart. Considering these aspects, a tool guidance is a must, and this will be done by a bush that is shown in the next frame. Here you can see a bush has been fitted here. A bush will be fitted here like this, and this there will be a small pin to fix it in position. This will how it will be fixed. So, this is we have explained the bush here. Here you can see the jig bush has been placed here, and this enlarged view. This is the plate, jig plate, in which the bush has been fitted, and the bush diameter, inner diameter is equal to the diameter of the drill, slightly bigger, and this is the pin which is holding the pin in position, so that during the reverse of the drill this does not go out, and as and when required the worn out bush will be replaced. Now, there is another part is consistently perfect locating. Now, friend, here is the locating by V block, that is okay, but what about this another locating pin is this one. So, this contact has to be assured, and every time this contact should be made and with equal force. Now, how this will be assured? During locating, before clamping, the clamping was not done, clamping was withdrawn, and a fresh rod was fitted in blank, and this was pushed in by finger, but this has to be pushed with the force, with the given force, with the constant force, with a small force, so that the contact is assured every time. Now, for that a system has been proposed. This is called a pusher. Now, this pusher, if you just push this pin out against the spring, there will be contact. If you release it, then under the action of the spring, this pin will apply a small force on the rod against this locating pin. So, this will assure absolute contact, and after it is fitted in, then clamping and other things will be done. Now, this will be worked. This the other view is like this. So, during clamping and machining, this lever will remain in this position, and this pin will apply a force at the center of the rod. Now, after the machining is complete, this pusher has to be withdrawn, it has to be dropped. So, this will be dropped, and with the help of manually, this will be done manually, this simply pulled and dropped, and this amount of rotation will be governed by this pin and by this cam, a slot. So, the spring will help actuation of this pin very quickly and effectively. And finally, the ejection. After the rod is machined, then this has to be dropped. This pusher tube has to be dropped. So, this will be dropped. Then this has to be removed. How can you remove it? And clamping has been withdrawn. So, a gap has been created here. So, there is no obstruction. Now, by this ejector, you apply a force in this direction by your thumb, by left thumb palm, and then will exert a force by your hand, and this will come out, and you can hold it and release it and replace it, and then this will automatically go back and put another blank here. Then you put it in position, then you clamp it, and then drilling operation will be done. So, this is how the work will be accomplished. Now, let us discuss some specific application example. Okay? Design of jigs and fixtures for some typical jobs. You can also some critical as well as typical, mostly typical jobs. Say example 1. This is the task is there is a disc, okay, hollow disc. You can call it ring also. Now, here 6 holes have to be made, blind holes, not up to this center, sorry, not this one, one hole here, one hole here, let us see clearly. This is the blank hollow disc with sufficient thickness, it has got thickness. Now, one hole has to be made here, one drill here, and one drill here, such 60° apart, one hole here, and one hole here. 6 holes have to be drilled like this, okay, and blind, not to the full extent. So, it is blind hole, and equispaced holes 6 holes and drilling. Task is example number 1, design a jig. Why jig? Because drills have to be made, so this have to be dual guidance. Design a jig for drilling 6 blind holes radially in a disc as shown, that is equispaced. So this is the disc, this is the disc in which 6 holes have to be made. Now how this will be done? This can be done in number of ways. One method has been shown here. You take a box like jig, hexagonal. Now this is hexagonal box, okay, hexagonal box which has got a mandrel inside. This is the mandrel, and this diameter of the mandrel, main part of the mandrel on which this blank will be fitted. This is the blank, okay, is fitted, and then this is clamped by, so locating and supporting is done by this part, cylindrical part of the mandrel, and this side of the jig plate. So axially and radially this is located, job is located. Then clamping, this will be clamped by a nut. You can use a quick acting nut also, then it will be faster, and inside there is a swing type collar, okay, collar or swing type, you know, a bush like. Now this is fitted, so locating, supporting and clamping of the blank is complete. So next, now the drilling operation. The drill will be working along this axis, okay, this is the drill, and in this case this is the drill. So drill position of the drill is fixed in the machine mostly. Now this, along with the job blank, this jig fixture has to be shifted and placed manually under this drill in this fashion, so that axis of the hole desired is aligned, this axis of the hole is aligned with the axis of the drill. This has to be done manually. This fixture or the jig will be placed on the bed, and manually it has to be adjusted so that it comes in the position, or it can be mounted on the table. This table of the drilling machine can be movable, you know, which is easy to handle, and you can bring the axis under the axis of the drill. Or if it is a radial drilling machine, then putting the job here, then you bring the drill in position by moving the radial arm. Anyway, so the axis of the drill and axis of the hole to be made, or axis of the bush that has been fitted, this is the bush, will be required to guide the tool, should be aligned, and this is mostly manually done. After doing this hole complete up to certain depth, that will be governed by a stop, the drill will be withdrawn. After the drill is withdrawn, what next is indexing. This is called indexing. So this indexing mechanism, that is equal amount of rotation, it's a part of revolution by 60 degree. In this case it has to be rotated by 60 degree. You rotate in this direction. So this position will come here. How this will be done? This nut will be loosened. Not like this. This will remain tight as it is. What you do? You hold this jig in your hand and then lift it and rotate manually by 60 degree and place it again on the bed or table under, so that the axis of the next hole is aligned with the drill. Now you do the drill again. After drilling, you rotate again manually by 60 degree and so on. This way, by manual indexing, you can get all the 6 holes, all right, and the accuracy of the location of the hole will depend upon the accuracy of the location of the these bushes, okay, with their holes. So this is manual, and accuracy may be slightly less, but this is manually possible. For convenience, one stop can be used here, so that again this block, jig block, can be placed against this stop on the table if it is clamped. Now let us take another example. Design a jig fixture, which is continuing, example number 2. What is the example task? Design a jig, again a jig for drilling 4 equispaced radial through holes. Now here you can see we are considering this time through holes, and 4 that is 90° apart in a ring or a disc as shown here. Now, this problem is very similar to the previous one, but the solution will be in a different manner, and this will give a simpler and more handy and more accurate possibilities. Okay. What is the task? Now, first you see the task. This is the disc or the workpiece. Okay. This is a ring which has got certain, this is the workpiece, this is the disc, the cross sectional view of the disc. 4 holes have to be drilled through from here to here with a given diameter of the drill known and equispaced, that is 90° apart, and this can be a batch production obviously. So, it should be located, supported and clamped conveniently and time to time or unloaded, loaded conveniently. And since it is a drilling operation, so the tool guidance will be essential, and that will be accomplished by a jig bush of this kind, maybe with pin or without pin, you have to decide. Now, how this will be done? See one by one. First of all, this blank has to be located, then supported, then clamped, then tool guidance and other things. Here, this is the jig, mounted on the bed. This is the T slot which indicates that this is the bed of a machine tool. On the machine tool, the jig plate has to be clamped, but before clamping it has to be assured that the axis of the hole to be made and axis of the drill should be aligned. Accordingly, this has to be clamped only for once for the whole production. Okay. Now, what you do? This nut will be opened, this job will be fitted in, this is pre-machined. So, this inner surface, outer surface and the surfaces, these are all machined. So, you fit into this mandrel. Now, here you see the mandrel, in this portion there is a recess. Why this recess? Two purposes: for better contact or stable contact. On the other hand, the drill has to given some space to complete the hole, because this is a through hole to be made. So, drill will come out up to certain distance. So, there should be recess, otherwise this will make hole inside this pin. So, this is recessed like this. So, after locating, now this axial location will be assured by this collar of the mandrel. So, this is the entire mandrel, one piece, and this is the collar which is resting against this collar, a pre-machined collar of the disc jig, and against this end face of the collar the job piece is located. So, this is not V block location, this is on mandrel. Now, after that this will be, so locating, supporting have been complete. So, next is clamping. Now, this clamping will be done by this nut. Now, this single nut may be a quick acting nut also with taper hole, that has been discussed in the previous lecture, and this is a collar, a swing type collar. It can be a swing type collar, it can be a swing type collar like this. So, the pin will be here. Now, this one, now you tighten this one. So, everything is complete. Now, you operate the drill. So, drill will rotate like this and will complete the hole. After understanding the hole is complete, this will move back. While going back, it is to be assured that this bush does not go along with it. So, this has to be fixed by a pin, all right. And now, after the completion of the hole, this now hole number 1. So, next hole has to be made. So, that requires indexing. Now, first of all, this, now before that, the clamping, in this case this nut clamps the workpiece or blank with the mandrel. But what about the mandrel? That mandrel should also be fixed in a position. How that is assured? That this is a pin called locating pin, another is a strong one. So, here this the cross section, this is the cross section, this part, if you take a cross section here as shown, say A, so this is a cross sectional view. So, here there are 4 holes, inside 4 holes there are 4 bushes, taper bushes, inside there is a taper pin getting in. So, when this working will be going on, when this when this working will be going on, the whole working going on, this will remain in position fixed, okay, so that the job does not move relative to the mandrel and mandrel does not move relative to the part and part does not move relative to the base, all are fixed. After the completion of one hole, then the pin has to be withdrawn, okay, by against the spring, and then this has to be rotated manually, okay, approximately 90 degree, and you release it. When you release it, this taper end will get into the next taper hole automatically, and since both of them are taper, this will be self aligned, the self locating, that is this will become coaxial automatically, and then this will hold this whole mandrel in position. Now you do the next hole easily. So the second hole is done. Again you, after the second hole is complete, then you withdraw this pin, then rotate this one again by 90 degree, release this pin, this will get into the third hole, this hole, and this will job will be also indexed, and this hole will come align with the drill, and you make this third hole, and similarly you make the fourth hole also by this kind of indexing. Now friend, again I remind you that compared to the previous one, you will recall, compared to this previous one where everything is done manually, this heavy load and heavy task, the shifting, locating, everything has to be done very carefully with lot of effort. Compared to that, this is easier. Only once fitted, the job is fitted here on the, and this remains fixed, the jig plate remains fixed, so that need not be moved, okay, and the locating will be done, is locating, supporting, clamping will be done on the mandrel, and this indexing will be done by this plate, this system very easily, quickly and effectively, that is rigidly. This pin should be strong enough which will not allow this mandrel to rotate or move at all under the action of the drilling force. Now let us take another example, okay, design of jig fixture continuation. Example 3, design a fixture for milling a slot on steel rod as shown. Now look here, this is a different type. This says that design a fixture, because this is a milling operation, milling a slot, so there is no drilling work or making any hole. So this will be a fixture which has to be designed. Now what is the task? Task that has been told, this is a rod, okay, straight rod, pre-machined rod here. One slot has to be made here, okay, one rod has to be made here like this. That means one slot will be made here. Throughout the length, a slot of rectangular section has to be made. Now this will be done in milling machine. You can do it by end milling cutter, you can do it by slot milling cutter, this type slot milling cutter, and other thing. Let us take one, say this type slot milling cutter. This is a slot milling cutter. Here the width of the slot cutter is equal to the slot width of the slot that is desired, okay. So let us choose accordingly. Now so this will be, how this will be mounted? The axis of the cutter will be always vertical, is a end mill type, this is a say vertical axis type of milling machine. It can be horizontal also, then the configuration will be just 90 degree rotated. Let us assume that the axis of the cutter is vertical, and this is the cutter, say maybe high speed steel cutter, or it can be a carbide cutter with a number of cutting edges, and when this rotates, it cuts the slot like this. This will cut this slot, this slot, and this blank, this fixture, this is the fixture, the entire body is the fixture, okay, this is the fixture. This is clamped on the table of the milling machine, that is the T slots, so they indicate that is a table, and this table will move in this direction. so that the cutter will remain in one position, the entire slot will be made throughout the length. Now, this is the work to be done. Now, we have decided that a fixture has to be designed for the purpose, for ease of locating, supporting, clamping, that is productivity and quality, consistency of quality and so on. How this will be done? Let us clean it. Here you can see that this is the blank. Okay, this is a rod like, is a straight rod, pre-machined rod with good outer surface and length, faces, all these things, periphery. So, you put it, so obviously V blocks will be suggested for locating and supporting, but since a slot has to be cut within horizontal vertical axis, so the job has to be held in this fashion and a V block will be in this fashion, not exactly like this. This is the usual way of mounting, but we can put in a position like this, one vertical face and one horizontal face with an angle 90 degree, and this is the recess or relief for ease of manufacture, cheap position and all these things. So, now this is the locating and supporting, but what about the axial location? On this side you can see that this is the rod is mounted on the V block, fine, placed, but what about the axial location? Whether it will be here or here or here or here, this will be assured by a locating pin. Now, this a plate which is fixed here, okay, and then there is a spring loaded pin. So, this face of the pin will be arrested here under the action of the spring, alright, compression spring. So, this end of the pin will arrest the face of the one face of the blank. So, this is for axial location and these two are for these other two directional locations. Now, this has to be arrest all degrees of freedom. So, a clamping will be required. So, supporting is strong enough here on the V blocks or the vertical plane surface, and with this further supporting and locating here strong enough. Now, clamping, this has to be held in position strongly. Now, since it is giving us force to support here and here, so there should be preferably another force acting in this direction passing through the same point, that will give very strong, rigid and stable support. This can be done by the strap. This is the strap. Now, this strap will be pushed down. As a result, this will apply a force in this direction on this, all right. So, this will be working. Now, this is a cam clamping. So, if when you push it down, this will push. Now, this is a spherical washer, because the strap may be inclined like this. So, washer, and when you put it down, this exert force and the strap will exert force on this. So, this is how the force will be applied on this. So, you understand that how the clamping will be done. Now, there is no question of tool guidance. This has been discussed, that what is the function of this. Now, I shall explain again. This contact point here on the locating pin has to be assured every time. So, against this sometimes it is done manually. So, by finger it is pushed against this before clamping, but to get a nominal force and assured force of same magnitude, a spring loaded mechanism can be thought of. So, there is a lever. So, this will be rotated, this will be hinged at here, this is pin here. So, this will be dropped here. After this, the spring, this will be placed like this, and you mount the job here from this side or this side, because there is a cutter, better you put from axially, and then freely, then you raise this one and put it back here. This spring will keep it in horizontal position, and as when required, this will bring it back, and the spring will push this rod again through this pin. So, this is called tension spring, okay, tension spring. So, this is the lever, tension spring, that gives a necessary force, okay, desired. So, what is now done? You can see the locating on the V block locating by the spin end, supporting on the V block and partially by the spin, clamping by this cam, quick acting cam, quick clamping by cam. The spring, there is a spring. What the function of the spring? The spring will, when this will be withdrawn, then this has to go up automatically. This spring will push it up, so that this, there will be a gap, and rod, the blank can be released or unloaded properly, but before that this has to be dropped down. Now, what is the function of this last one? This is ejector. Now, this pin here, look at this pin. This is a very double acting pin. When it is under this condition, under the action of the spring, this end is rigidly held at a distance, because this end is arrested by the surface. This will be used for locating, but after the job is over and this is dropped down, this is withdrawn, then this has to be pushed out smoothly with the help of this ejector. So, by your palm or one hand, this has to be pushed in this direction, and this will exert a force, and this will automatically come out. So, this is how it can be released. So, locating, supporting, clamping, pushing and ejection, all this can be easily done. Now, these are few examples, lot of examples can be cited, and it has to be designed accordingly. But you have to remember that locating, supporting, clamping, tool guide, pushing and ejection, then other factors like say chip removal, chip disposal, and all these things have to be taken care of. Again, I remind you that so far our discussion has been done today. These are the design of the configuration and the principle of working, fulfilling the basic requirements like locating, supporting, clamping, tool guide, ejection, etc. But friend, what is design? This is comprised of number of elements. Now, all these elements have to be designed. What is the design? Design means selection of the material and then the dimensions of the parts, such that these parts will not fail mechanically under the action of the forces coming from the operation. So, after this configurational design and design fulfilling the movement requirements, location, supporting, clamping, part by part each one has to be designed separately, that is material selection and then determination of the dimensions, diameter, length and all these things, so that design is complete. So, this is how this will be done. So, friend, thank you all. Now, I given you some few, only 3 or 4 examples, but remember it can be 100 types, but if you follow this basic principle, it will remain more or less same. So, follow these basic rules. First, you decide whether jig fixture will be used at all or not. If you decide yes, jigs and fixtures application will be economically viable, justified, then you decide whether jig or fixture. If it is to be drilled or hole or something like that means use of drill or reamer or some counter boring tools or similar tools, rotating tools are required, then bushing will be required for the tool guidance and it will be automatically jig. And after that, one by one you have to design for locating, supporting, clamping, and then tool guidance, okay, then ejection, then pusher for assurance, ease of loading, unloading, all these factors have to be designed. So, this is very interesting subject and now you can apply. Thank you.